Ladies and gentlemen, I'm going to lead you through finding the equation of a quadratic function. This is a picture of the function that you're dealing with, and the data table along the side gives you the coordinates of the points. Your task is to find an equation of this line in terms of x and t. We're going to go ahead, though, for now and relabel the axis as x and y, because that's what you're used to, and we're going to use math terms now. So here's some hints. The standard form of this equation is going to be y equals ax squared plus bx plus c. That you should recognize as a quadratic equation. In that form of the equation, c is the y-intercept, b is the slope of the tangent to the curve at x equals 0, and a is the coefficient of the x squared term. When the absolute value of a is less than 1, the curve widens, and when the absolute value of a is greater than 1, the curve narrows. Okay, let's slow down and take this one by one. First, finding out c. C is the y-intercept. I've circled the y-axis, and the y-intercept is the location where the line intersects the y-axis. So you should now be able to record what you think the value is for c. Next, b is the slope of the tangent to the curve at x equals 0. In your math class, b may not be described this way. For the sake, it is mathematically accurate, but it's certainly the right way for us to think about it from a physics sense. So to find the value for b, you're going to look at the slope of the tangent that's shown here in orange. So you're going to record what you think the value of b should be. Okay, the last thing we're going to address is figuring out a, the coefficient of the x squared term. And that's a little bit more complicated. Hopefully, if you look at this, you ought to be able to tell whether or not a is going to be a positive or a negative number, simply by looking at this graph. One of the things that I would suggest you remember is that smiles make you happy, and that's positive. So a curve that looks like a smile or part of a smile has a positive a coefficient. This looks like a frown or part of a frown, and a frown makes me sad, and that's negative. So the coefficient of a will be negative in this case because this is part of a frown shape. Okay, next. Let's compare a little bit about the ideas of the values of a. If a is a fraction that's less than 1, so a fraction that is somewhere between positive 1 and negative 1, then the curve is going to widen out. So you see here in red an example of what a curve would look like for an equation that had a value of a equal to negative 1/2. Then the blue line shows what kind of a curve we would have if the value of a was negative 20. So negative 20 is clearly larger than 1 or negative 1, or at least larger than the absolute value of a is larger than 1. So this shows that it's narrowing. So at this point, you should be able to now narrow this down somewhat so that we ought to be able to identify what the range is for a. Now let's switch back to our equation. So now you know the range for the value of a, you know the value of b and the value of c. Our next task is to shift from math's x and y axis into physics that has the axis labeled as t and x. X in physics means position. So your task right now is to rewrite the equation y equals ax squared plus bx plus c using instead t for the horizontal axis and x for position as the vertical axis. So do that first. Then in that equation, go ahead and drop in the values that you have determined for B and C. And if you're unsure yet about the value of A, then you can just leave an A in there for now. We've made lots of progress. That's really good. Let's figure out what else we might be able to figure out about A. Okay, so if we look here, notice that I have a couple of columns that I've added onto this table. In column A, what I'd like for you to do is I'd like for you to place in this cell right here the value of the difference in these numbers. So 395 minus 400 is negative 5. 380 minus 395 is negative 15. So I'd like for you to do that all the way down, and you'll need to pencil in a new column on your paper. This column wasn't provided on your paper. Then for the column B that is over on this side, excuse me, you're going to now compare the values that you got in column A. So I want you to do the same thing you did before. I want you to take this value of 15, negative 15, and subtract from that this value of negative 5. So you should find that that change is negative 10. So continue that process all the way down, and you should find out something awfully interesting in this column. And when you've done that, you should see a very distinct pattern for a value in this column. That, ladies and gentlemen, is the value for A, the coefficient of A. So now you can finish your equation. Good job.